where this system was the government runs. The system decides whether you are. Yeah, like if your son passes it up, pretty much the committee will come on.
Oh, so great. Okay. So I was, how do we contact my dad? Not yet.
All right. So as we're moving into our last few lectures, things coming up, we're going to do a group quiz today. This will be the last quiz that covers the Chapter 18 material. There's no mastering tonight. We're going to have mastering Wednesday night, but by the end of lecture today, you should be able to do the mastering for Wednesday night. And if you're taking the test early, make sure you do the mastering before the test, because it's going to cover the last material on the test early. Wednesday, we're going to bring Chapter 19 notes. Right, Friday is Good Friday, so we will not have class. Then next Monday, we're going to finish up 19, maybe answer some questions that people might have. We'll do the exam on the 23rd. And then the last 2 days of class, that Friday and the last Monday, we'll wrap up whatever we haven't covered and do some review. Yeah, Paul?
Do we have lab this week?
Yes. You had it off last week. You definitely have lab this week. Any other questions about stuff coming up? So how many lectures is that? That's 2, 5, 6 lectures left or so?
Oh, man.
Yeah, aw. Sad. Then you'll move on to bigger and better things. All right, so where we left off on Friday, we were talking about what if we are not at 1 molar. We're not at standard states. We're not at 1 molar. We're not 25 degrees Celsius. We're not at 1 atmosphere. We're at some combination other than that. We're going to use the Nernst equation. The Nernst equation relates the standard state cell potential to Q, which tells us where we're at in relationship to equilibrium, and gives us a new cell voltage. So what we're going to do today is we're going to do some practice problems on that and then talk about non-galvanic cells. So let's say, for example, let's say we have the following cell. So I have zinc solid reacting with water and hydroxides to produce a zinc hydroxide compound. That's kind of hard to see. This is a 4. And hydrogen gas. All the aqueous compounds are at 2.5 times 10 to the negative second molar. We'll leave hydrogen gas as 1 atmosphere. We need to find the standard state cell so that we can then compare it to its non-standard state. So standard state, then we'll do Q, then we'll do the non-standard state cell potential. All right, so what's the first thing I need to do in order to figure out what my standard state cell potential is? Figure out who's being oxidized and reduced. So would you like to do the zinc half or the zinc half or the water half? Zinc? Okay. All right, so those are the obvious things that go with the zinc, correct? We have zinc and zinc. This one's a solid. This one's aqueous. What is the oxidation state of the zinc solid over here on the reactants? 0. How do you know it's 0? It's a solid, right? It's in its normal, ordinary state, so it's 0. All right, so now we have to figure out what is the oxidation state of the zinc over on this side. So, since we have a zinc combined with a hydroxide, is that compound ionic or molecular? It's ionic, right? Because what do we know about OH? They're always stuck together, and because they're in the parentheses, they're stuck together. So if they're stuck together, what's OH's charge? -1. Now if I had a zinc, then an oxygen and a hydrogen, that's different. This is a zinc parentheses OH. I thought you guys were ready for a level up and challenge. All right, so how many hydroxides do I have? 4. So what's the total charge of the hydroxides? 4. What's the overall charge of the molecule? So what must be the zinc? +2. All right, so the zinc has gone from 0 to +2. Is that an increase or a decrease in its oxidation state? So is it an oxidation or a reduction? Increase in oxidation state, that tells us it's an oxidation. So do I put electrons as a product or a reactant? Product, and how many do I need? 2. All right, so then we need to finish mass balancing this, right? Because now I got the zincs and the electrons all sorted out. What's going on here with these oxygens and whatever's hydroxides? Are they balanced? No. Looking at the overall net equation, are you balancing in acid or in base? Base. So what's the easiest thing we can do to balance this out? We could add water, but I know for sure I'm in base. So I can just go ahead and add some hydroxides. I could add water and then balance out the protons, but I know based on this up here, I'm in base. So I'll skip right ahead to the base adding step. You guys look super confused. Good, good, okay. Is there something I can specifically help out with?
You don't have to add the OH to the other side.
Because I already have them. They're already there. I'm just trying to balance it out this side. Okay, all right. Let's look then, what must be the other compound undergoing a redox reaction? Water. All right, so let's take a look at the water half. All right, we'll take a look at what's the oxidation state of a H in water? +1, and how many +1s do I have over here? 2, okay. What's the oxidation state of hydrogen gas? Why is it 0? It's its normal standard state, so we're going to call it 0. We'll call this guy over here +1. So, how many electrons then do I need to go from, actually, yeah, no, that's right. Let me get rid of this 2 for now, because it throws off my stoichiometry. So I have 2 +1s going to hydrogen gas. How many electrons do I need to go from here to there? 2. Good so far? I'll put that 2 back in, but for now, it's throwing off the stoichiometry. Because I have to double this over here, because, right. All right, so I have 2 electrons in that. That's good, that's good. How are we turning in terms of mass balance for that particular question, this half reaction? What am I messed up on? Oxygens, okay. What are the 2 different ways we could add oxygen? We could add water, or we could add hydroxides. If I added water to this side, what would happen? Be too many H's, and it would cancel out with the water I have on this side. So we're going to go ahead and add some hydroxides. So now how many hydrogens do I have total on this side? I got 3 H's and 1 oxygen. I got 2 H's and 1 oxygen over here. So what's a way I can, what if I do that? So now how many total H's do I have on my products? 4. And how many oxygens? 2. All right, so what do I need to do over here? Yeah. It was eventually going to be 2. I was getting ahead of myself with what you guys had. All right. So are we good now in terms of, oh yeah, question first.
What is the water's overall charge in the reactant side?
Overall, water is 0.
So why do we add 2 electrons to get back to 0 in the product?
Because we have 2 hydroxides on this side. So the overall charge of this side is -2, and the overall charge of that side is -2. And I'm going from +1 to 0. So in order to go down the number line, I have to subtract 2 electrons.
Alright.
Yeah?
What's the +1?
That's with the H, when we're deciding its oxidation state. You can ignore it. Yeah. I was saying oxygen has an oxidation state of -2, which means that both the H's together must be +2, which means they're each +1. That was it. That was just, if it's confusing, then don't do that. All right, so hydrogen is going from +1 to 0. Is that an oxidation or reduction? Good, good. It's the other one we haven't done yet. So now, an oxidation or reduction. Can we add them together as is? Or do I have to fix something with the electrons? No, we're good, right? Because I have 2 electrons going in, I have 2 electrons coming out. Would it make this reaction as my final if I combine them together as is? Yes, good, because, right, I have 2 waters and 2 waters, 1 zinc, 1 zinc. I have 4 over here, but 2 over there, so I'll be left with 2. Make my zinc hydroxide and my hydrogen gas. Good. So now I know my 2 half reactions. What's the next thing you would do to figure out E0? You would go to the tables and figure them out, or I'll just tell you. In the interest of time, I will tell you. Sorry. This one should be minus. So this one's minus 1.249, and this one's plus 0.828. All right, so now I have my 2 half reactions. What order do I subtract them in? All right, so which one's the cathode? Yep. All right, so is this reaction spontaneous or non-spontaneous as written? Spontaneous. Okay, so now we are ready to figure out what Q is and then figure out what our non-standard state cell potential is. Yes.
When would we use this, I guess the E naught of the cell is equal to the cathode minus anode versus the E naught of the cell is equal to 0.257 over N ln K?
You would have to know K.
Okay.
Right, so either you'd know K based on all the concentrations or whatnot, you'd have to know you're at K and not Q. So you will never use K to find E0. You'll always use E0 to find K.
Okay.
Because the E0s come from the table, and so we'll always know E0 based on your half reactions.
Okay.
And then you'll use that to find K.
So
Or
that's a way to find K.
yes.
Okay.
Yep. All right, so how do I define Q? What over what? Products over reactants, right? So what is a product of this reaction? Oh, question first. Sorry, Jim.
For the E knots,
Mhm.
for the second bullet, in the chart it's negative, why do you change this one?
Because I probably just wrote it down wrong. Let's see here.
Because you have a weak spot, like the first one should be positive, the second is negative.
In that case, I just wrote them down wrong. Go ahead and swap them. Typo on my part. Make that a plus. Make that a minus. My fault. In my excitement this morning to come up with an amazing problem, apparently I got ahead of myself. Alright, it should, I don't think, affect the outcome. E0 cell. Yeah, so excited this morning. Let's see. All right, so now in my new corrected, thank you, Jim, fixed problem, am I now spontaneous or non-spontaneous? Non-spontaneous. Equally good. Fair enough. Let's see if I can get it on here. All right, so we're doing products over reactants to find Q. And I have this zinc compound that I know based on what the problem told me. 2.5 times 10 to the negative second. What about this hydrogen? Do I need to include it? I mean, you can. Right, it's going to be 1, but it doesn't have to be included. Your option depends on how meticulous you want to be. All right, looking at our products, how many products will be included in my Q? All 3, 2 of the 3, 1 of the 3. Just 1. How come I don't include zinc? Sal, how come I don't include water? What about this guy? Yes, have to include him. What do I have to do? I gotta square it. All right, is my Q greater than or less than 1? Greater than 1. So what does that tell me about the concentration of products versus concentration of reactants? I have more products than reactants. So which way would you envision it having to go to come back to equilibrium? Back towards reactants. Okay, so what we'll see is whether or not our non-standard state E tells us the same thing. It should. All right, so now we're ready for E. Let me get my nearest equation. The exact same form we had earlier. Should be.
Is that because we're at 1.0 ATM? We use 0.07.
I thought we weren't at
So
two.
RTO.
Oh, right. That is for RT over N. And I didn't tell you anything about temperature. RT, oh, sorry. Over F. There we go. RT over NF.
Okay.
And so if I didn't tell you anything about temperature, you can assume you're at 25 or 298. And so this part will still be true.
Okay.
If I do something crazy, like decide to do it at 300, then you're right. I can't use this. I would have to plug back in R and T over N and F.
Okay.
I probably won't do that. That's a lot of things, a lot of places to go wrong. All right, so we know E, because we just found that. What is N for this problem? 2. How do you know it's 2 electrons? Right, because that's what we need to balance both the equations. All right, let's see what this turns out to be. So is our E less than our E standard state? Right, E standard state is this, and we're at a potential even less than that. So that tells us all the same information. That Q tells us we have too many products. This tells us that it's non-spontaneous as written. It has to go back to reactants, become spontaneous, which matches up with what we know about E0. So all the pieces should tell you the same bits of information. Is it more or less spontaneous than at standard state? It is less spontaneous. True. Do you want to do another one?
Yeah.
Yeah, okay. Get myself another piece of blank paper. I'll go crazy. I'll pick it at a different temperature. We'll go ahead and try it. We'll go 40 degrees.
Oh, Celsius.
Celsius. Whoa. Lots of curveballs.
Whoa. You
Whoa.
can do that on set.
Depends how sparkly I feel, I guess, between today and tomorrow when I write it. If we do awesome today, maybe like jazz hand sparkly. We'll see. If I'm like, you guys totally got it. I'm not worried about you. Then I'll do this problem. If I'm like, uh-oh, we'll see how the quiz goes. If I'm like, uh-oh, we'll ramp it down a little bit. So after the quiz today, I'll figure out my level of difficulty.
No, that's good.
No, you can have 273.
It's just 273 from both.
Yeah. Yeah.
I used to add 273
Oh,
to
that's
40.
not bad. Well, I mean, no, wait.
Calm down. It'll be okay.
You'll be okay. We'll work it out. All right, let's say, oh, okay, we'll go real challenging. We got time. I leave myself enough space in my parentheses. All right, so my equation is partially balanced. So what we need to do is need to balance it first in acid, then figure out E0, then figure out Q, and then figure out E non-standard state. I'm trying to balance, we'll do as fast as we can, so you guys have time for your quiz. All right. Do you want to do the lead half or the permanganate half? I'm going to do the easy half. We'll do lead first. All right, is this the oxidation or the reduction? Oxidation. So how many electrons do I need as products? 2. Done. Let's do the other half. All right, so I've already done the oxidation half. This must be the reduction half. So what is the oxidation state of the Mn? Except it's overall -1. +7. All right, what's the oxidation state of this Mn? More than 2. +4. So how many electrons do I need to go from 7 down to 4? And where do I put them, as a reactant or a product? Okay.
So we don't put in coefficients?
Not yet. No, balance first, then we'll do the coefficients. I think it's less likely to mess up if you do it that way. Yeah.
But we're doing these kinds and they're partially balanced on the top.
Mhm.
And we have to balance them so that we can add input electrons using the equation, correct?
Mhm.
When we get to this step, we just...
You can kind of skip ahead. Yeah. Yep. Because you're right, balancing the rest of it is not critical to figuring out E0. Yep. Yeah, so once you get to this step and you say, oh, I know I need 2 electrons and 3 electrons, and it's clearly an acid, you can kind of skip ahead and go right to the table. Like, you know, what do I have to multiply the top one by to balance it out? Okay. What do I have to balance the bottom one by?
2.
Okay. So how many electrons will N be equal to? So then you can use your smarts and be like, okay, well, I know I'm looking for MnO4 and some acid to make this. Where is that on the table? Oh, right here. MnO4 solid, and that, and that, and that. E0 is listed as 1.21. Does it matter that on the table it's written as the solid and some protons? No. Good. What about lead? Let's find my lead. Oop, there it is. Lead plus 2 and 2 electrons make lead solid, negative 0.13. But we just multiplied by 3. Do I need to do anything about my E's? No. Okay, good. Trick question. Good. So, all right, so now I need to find E0. So, who is the first number to be subtracted from the next number? Okay. Is this equation spontaneous as written?
Yeah.
Good. Okay, so now let's figure out Q. So how many of the 3 possible products will be included in Q? Just one, just the lead, right? Now, this is where you have to pay attention to what you've been doing. How many leads would be in my final thing? 3, so I'm going to do this. Cube it. So if you don't write the whole thing, that's fine. You just got to keep track of what would the final equation be in terms of stoichiometric coefficients. So some people may want to write out the whole thing so you can keep it straight. If not, totally fine. All right, what of the 3 possible will be on the bottom? How many? 2 to the 3, 3 to the 3, 1 to the 3. 2, okay. Does this guy get a square or cube or something? gets a square, because I would have 2 of it in my final. And that would just be 8, because that would be how many protons would be once you balance it all out. All right, let's see here. What does that turn out to be? 0.1 cubed divided by... Greater than or less than 1? A little bit greater than 1, right? Assuming I plugged it all in, right? 4.44 times 10 to the 4th. So does that tell you, do I have more products or more reactants? More products, right? Because it's much greater than 1. So should my final cell be less than or greater than? Should be less than. Let's find out. Okay, so what do I use as R? Yeah, the 8 point, Okay, my temperature is 40 degrees Celsius, so it should be like 313, I think, 313 Kelvin. All right, so what do I use as N? 6, good. And anyone happen to have F off the top of their head yet? I do. I give you all the constants. Not the formulas. But I know you guys got it. There's only like a bazillion in this chapter. Between this one and the last chapter, there's only like a million. Okay, Ks and Ks and moles. Moles. I forget what it is. Joules per mole volt. Ln of, I ran out of space. 4th. All right, here we go. 8.314 times 313 divided by 6 times. Times the natural log, 4.44, and the 4th, not possible 4th. Did it change it by a dramatic amount? Not really, right? Because we're not a very high like this one's kind of a high concentration, but the other guys are pretty low concentrations. All right, in that case, Wednesday we'll finish the last little bit about electroplating. It won't be on your test. No. Right, the last one. Don't worry about it. Yeah. All right.